Hi, so today we would be discussing on the basic architecture of a data warehouse being implemented generally across industries for the business intelligence purposes. So you know that all the organization today has multiple data sources. So one may be on sales, one may be on marketing. So if it's a bank, it has its own core banking databases on maybe delivery channels like internet banking and so on and so forth. So all this data will be pushed into this staging area where it would undergo the extract, transform, and loading process. So that's what you call as ETL. So all of this data can be from different sources, like one may be from a database, mostly from databases, but sometimes it can be even flat files from different bases based on the servers and all those things. So the extract part, it basically extracts the data from each of these sources individually onto the staging area and transforms it according to the requirements so as to push it to the data warehouse. The loading part, in essence, can take different methodologies. So one of which would be the full load. So whatever historically had the transactional data in one of the, say, sales will be pulled in a full load. But generally, most of the organizations having once implemented the warehouse would then have an incremental load. So what's exactly an incremental load? So I'll just go to that. Yeah. So incremental extraction is nothing but see. So what you do is like based on the either based on time or either based on modification, you just extract the data from each of the sources on the staging and then to the data warehouse. So on a daily basis, this historical transactional data will be extracted, transformed, and loaded, and then pushed in to the warehouse. And warehouse architectures can differ a lot, and we here mainly discusses this warehouse based on the dimensional architecture in general. So what exactly is a dimensional or star schema? Is nothing but a denormalized uh, uh, database schema or architecture that has the advantage of greater speed in retrieving information. So since data warehouse has uh, huge information, not just the recent transactional information, it's very imperative to have speed as one of the main consideration for generating reports. So here you have a fact table that is at the center, which basically holds the numeric data or aggregated values, and the remaining dimensions or around this fact will have description or descriptive information regarding the aggregate values, or so to speak. So these dimensions, like product, location, or organization, or all of these, basically describes the who, what, where, and when of the data, or yeah, the data. So it's basically the descriptive portion of the information. So in actual implementation, how it's not just limited to the star. So it's a lot of snowflakes is implemented. A snowflake, to put it very straightly, put it squarely, is nothing but multiple layers of dimensions from the facts. So you can say these dimensions are normalized. Not the entire star schema is not normalized, but just the dimensional tables are normalized. So why is it done? It is done because these normalization of dimension or descriptive information would reduce redundancy and thus increase the storage and also the speed to the optimum or better levels. So yeah, and finally, you would see, and this is how the data warehouse is implemented in the star schema. And there's a data mart layer. So each of the departments or line of business within the organization has particular requirements with respect to the reports that needs to be generated and the insights that needs to be obtained from that. So these data from the larger data warehouse are actually pushed into the data mart in a specific regarding to the specific line of business. For example, in this case, you have the purchasing line of business in one data mart, you have the sales related data onto another data mart. And it is from these data marts that the visualization tools and reporting tools generate the visualizations and graphs and so on and so forth. Yeah. So right now, we will go to a small demonstration using ClickView. So this is not really a very good demonstration for ETL, but as you know, ETL is requires a lot of proprietary softwares and informatica and so on. So I will just demonstrate on how to connect with a data source and just extract and load a very simple data just like that without much of a transformation, and just show you a star schema, how it is being generated. Yeah, so I'm just putting a control E, it's just loading. Yeah. Oh, yeah. These are just the default values. Right now, I will connect to the source databases. So here in this case, in order for demonstration, I'm connecting to a database within my own system, just assuming it to be a business source data. Yes. So this database is hosted in a SQL server within my own computer, and I'm just connecting to the insurance database. Yes, and we'll just save it. Oh, yeah, sorry. I will just save it as ClickView 2. Yeah, I will just put two more files. It's not necessary for you to really put this one, but as a standard practice, you can just name it. So whatever scripts that literally loads the dimensions, I'm just placing it over here. Here in this case, I'm selecting the claim costs, the claim costs category, the claim type, and the dimension member, and probably the postal code as well. So you must understand, I'm not really doing any kind of much transformation or any selective selection. In this case, I'm just retrieving all of the data as it is, just using a select query. So the fact around which we need to have these dimensions is nothing but the member claims. So all of this claim cost, claim category, everything describes about the fact member claims. And so after all this, we have to just reload. So it is fetching data from those tables. So I'm just selecting all of these columns from all of those tables, and yeah, so we'll just see the model. So this is fact member, and these are all the dimensions surrounding it. Yeah, so this dimension. So all of these dimensions describe this fact on member claim. So the SID type claim, the dimension claim type is connected to the fact member claims using SID claim type. So in actual implementation, we also have surrogate keys to identify each of the records between these two tables. And the SID claim cost connects with the dimensional claim cost and fact member claims and so on. And this portion describes the normalization of the dimensional aspect of claim cost. Okay. And this is just a simple demonstration as on how this data is extracted and made in the star or snowflake pattern. We will try to create a simple chart report out of this thing as on how these reports are generated from this underlying data. We will say claim amount by claim type. Bar chart, because I really want to compare the amount between these claim types. So the one which I need to have as a description is probably claim type code is not really understandable. For readability, I will add claim type description. And next, yeah, here you can just select whatever the, so we'll just select the average claim type, claim amount per claim type. So claim amount, claim paid amount. Okay, claim paid amount. And you can just paste it and it's good to go. And next, yeah, it should be fine. So here you can see very clearly that, sorry, yeah. So the average claim paid amount is more in the case of terminal illness benefit claim and in the case of death claim. So the income protection and total and permanent disablement has very less of insurance claim in this regard. So this is a very simple example of how you basically have these flow right from the data sources to staging to implementation of the data warehouse through the ETL, after the ETL in the respective schema, and then pushing to data mart, and how the reporting tool literally retrieves this data and then presents the visualization. So in actual reality, there are, as you know, there are multiple tools to handle each of these areas with incremental loads and ETL done specifically apart. So we will have further more visualizations using Tableau to have an understanding and explanation using Tableau as a tool for business intelligence as well. Thank you.